Hey guys, so quick video coming at you about cell transport. Right? So this is about how cells move different molecules in and out of themselves. There are two main mechanisms that you need to look at. The first is passive transport and the second is active. So starting with the passive transport, we have the main mechanism of movement of molecules in and out of cells, and that is through diffusion. And so diffusion is the tendency of molecules to move from an area of high concentration to an area of low concentration in net movement. And so in a space where you have a lot of something in one area and less of that something in another, they'll move from the place where there's a lot to the place where there's a little bit. And so in context of cells, got this little model here. Right? We have red molecules and we have galaxy-colored molecules. There is a high concentration of red molecules outside of the cell and a high concentration of galaxy-colored molecules inside the cell. Right? And so because there's a high concentration of red outside, they will have a net movement into the cell where there's a lower concentration, whereas the galaxy-colored molecules will have a net movement out of the cell because there's a high concentration inside, a low concentration outside, so they move out. Yeah. And so this is termed moving along the concentration gradient. Okay? It's moving with the concentration gradient, moving down the concentration gradient. Any of those are ways to articulate the appropriate movement of molecules when they are obeying the principles of diffusion. Okay? And so when molecules are going by diffusion, okay, so they're going from a high concentration to a low concentration, the cell does not need to exert any force on those molecules. The molecules will effectively be doing it by themselves. And so when we do diffusion, when our cells are diffusing molecules back and forth, it requires no energy on the part of the cell. When the cell is not using energy to move those molecules back and forth, that is what we call passive transport. Okay? The cell is not engaging in this activity, it's just passively letting things in and out. Okay? Passive transport, no energy from the cell. Okay? So now small nonpolar molecules will always be crossing the membrane in accordance with the concentration gradient. Right? Because small nonpolar molecules do directly cross the membrane between the phospholipid bilayer. Right? There's nothing to stop them from moving. And so they'll always go from a high concentration to a low concentration across that membrane. Other molecules, however, such as polar molecules, ionic molecules, large molecules, right, will not directly cross that membrane. So if they are going to move in accordance with diffusion, they need to use a protein channel. If you supply them with that protein channel, a protein channel that they can fit through, that's appropriate for them, they will then move from a high concentration to a low concentration of their own accord. Okay? Still no input of energy from the cell, so that is still passive transport. Okay? And we call that facilitated diffusion. Okay? And so that's when the molecules require a protein channel to move from one side to the other, but do not require any energy input from the cell. Facilitated means helped, right? To facilitate is to help, and diffusion is diffusion. Alrighty. Then we move on to something a little bit more interesting. Okay? If a cell wants to move a molecule against the concentration gradient, it wants to move it from a low concentration to a high concentration against the natural principles of diffusion, it can do that. Okay? However, that cell must exert some energy in order to achieve that goal. That energy is usually going to be coming from ATP, the molecule, right? And so in the model I'm about to show you, I've utilized ATP to demonstrate how this mechanism works. Okay? There are occasions where other sources of energy are used, but more often than not, it's coming from ATP. Okay? The cell also requires the use of a protein channel, because we're actively pushing this molecule one way or the other, and so we need something to physically do that. So we need the energy to do it, and we need the physical active guy to do it. Okay? And in this case, the active pusher is the protein channel. And in this model, as is most of the time, the most often situation. Bad Englishing, but okay. All right. The energy is coming from the molecule ATP. All right. So in this model, I have a high concentration of triangles outside of the cell in the extracellular area. I have a low concentration of triangles inside the cell in the intracellular area. This cell, however, hates triangles. It's like triangles are the worst shape in the whole wide world. Get them out of me. I absolutely abhor triangles. And so it has a protein channel that's designed to move triangles out. And this protein channel doesn't move triangles in, it only moves it out. And so it's shaped in a way that fits triangle molecules, and it is shaped in a way that pushes them out. So the first step of this process is that the triangle molecule will engage in the active site of this protein channel. Right? There'll be an area that fits the molecule and grabs the molecule, grabs it. Okay. Once that molecule is grabbed, an ATP will swing by. Okay. It will engage with a different area of the protein. It will drop off one of its phosphate groups. So it will attach a phosphate group to this protein. Okay. It will leave as ADP. Okay. So in order to attach that phosphate group, it had to break one of its bonds. And that's where that energy story comes from. We released energy by breaking that bond and shoving that phosphate group onto the protein channel. Okay. By attaching this phosphate group, we change the shape of the protein channel, and that change in shape pushes the triangle up and out. And finally, the triangle is out of the cell. That's our last step. Okay. And our protein channel will go back to its original shape. The phosphate will fall off, and then we can just repeat the cycle all over again. Okay, so that's active transport. It used energy to move a cell, a molecule rather, against the concentration gradient. So this is called a pump. This is an active transport pump because it's pumping the molecule. Okay. We have another form of active transport as well. Okay. And so it is endocytosis and exocytosis. They're both pretty much the same mechanism except for one's going in and one's going out. And so this is utilized by cells to move really big molecules or to move a lot of molecules at the same time. Okay. And so the cell does this. And let's look at endocytosis first. Endo meaning in, cytosis referring to the cytoplasm. Okay. And so in this case, we're trying to suck this big triangle into the cell. Okay. It's too big to go through a protein channel. So the triangle bumps up against the membrane. There are receptors that identify, oh, this is a triangle, I really want it. Okay. The cell then extends its membrane around the triangle. So it's engulfing the triangle in its membrane. Eventually, the membrane wraps all the way around the triangle, and then it pinches off. And so you get that molecule wrapped up in a bubble of membrane. We call this a vesicle. The bubble of membrane is called a vesicle. And now it's ready to be used. And so if this is like a food molecule for the cell, it's called phagocytosis, P-H-A-G-O, cytosis. And if this is a liquid, like a water, it's called pinocytosis, P-I-N-O, cytosis. Just some words, in case you wanted to know some words. There you go. Exocytosis, same idea, but backwards. I have a large molecule inside the cell. I want to get it out. It bumps up against the cell membrane. It gets wrapped up in the cell membrane, and then it gets spit out in a vesicle. Cool. So those are all of our mechanisms of transport. We have passive transport, where the cell does not need to use energy. The molecules move from a high concentration to a low concentration. That includes regular diffusion, simple diffusion for non-polar small molecules, and facilitated diffusion for all molecules that require a protein channel. And then we have active transport, where the cell is purposefully moving a molecule from a low concentration to a high concentration. It requires energy input from the cell and requires use of a protein pump. And finally, as our last form of active transport, we have endo and exocytosis, where we are moving either a big molecule or a bunch of small molecules all at once. And that happens by engulfing those molecules in the cell's membrane and then moving them in or out. That's it. All right. Bye.